So mostly what I'm seeing here is maybe there's just some trouble happening with slope. Maybe particularly, especially for these first two, it's when we represent slope with function notation, which looks a little weird and it is a little tricky. It's something that'll come back and get emphasized again in 141, but I like to start to show you some of those function notation pieces now as well. So for this first one, I'm just going to run through your 4 questions and kind of try and point some things out, maybe do them a little more thoroughly and maybe not. So if I don't do enough and you're still feeling stuck, do let me know. But I would say the big thing for this first one is that this is really just giving you points in function notation. So always the input in parentheses will be like your x value or whatever variable you're using. This is x. So this is saying when x is -5, y is 4. And when x is 3, y is -2. So your first step here would be to find a slope, and then you can plug one of those points back in to find a y-intercept. So for example, for your slope, it could be 4 minus -2. You get to pick the order, but once you choose the order, I've said this is my point number 2 and this is my point number 1, you have to stick with it. So if 4 is your first y, -5 has to be your first x. So that would be your slope calculation. And this isn't needed for this one, but it'll tie into the next one so that you're maybe starting to see how this looks in function notation. The way we would say y1 in function notation is f of -5. And the way we would say y2 for this problem in function notation is f of 3. And that's all over -5 minus 3. Or we can even go one step further and say slope is going to be f of -5 minus f of 3 all over -8. And if you had flip-flopped, which was your point 1 and your point 2, it would reverse that order on top and you would get a +8, but it's all the same thing. It doesn't matter. But what I hope you maybe see is how similar that is to what we're looking at here. That looks a lot like a slope. F of 5 is your y value when x equals 5, so that's like your y2. F of 3 is your y value when x equals 3, so that's like your y1. And the only thing that you have to be careful about is that the denominator really is your x2 minus x1, which your function notation also tells you that your x2 is 5 and your x1 is 3. So that 2 does in fact match up. I'm not planning on tricking you by making them not match up, but I just want to be clear that you could make a fraction like this and it wouldn't represent slope if that denominator wasn't actually your xy, your x2 minus x1. So really here, you're not being asked to do any work to get your slope. It's just a translation question. It's just recognizing that this right here says slope. That's what it says. Your slope is 1/5. So you're being given the point 15.9 and you're being given your slope is 1/5. So again, in this one, that just leaves you with the step of saying, okay, I could set up my y equals mx plus b. And this is if you like to use slope-intercept form. If you like to use point-slope form, this will look a little different, but that's great as well. What you would need to do is say, well, I know that when my x is 15, my y should be 9. And if you plug those in, you should be able to solve to find your b. And then that's the equation you're going to give as your answer to this one. So that's what I'm seeing here is just that function notation piece is maybe throwing you off just a little bit. Word problems can just be tricky in general, but I see it looks like you were doing okay with some of them and this one got you. So maybe it's that messy fraction slope or something along those lines. I like to draw these on axes, but something to remind yourself what you have. We are getting pressure as a function of depth, and the depth is in feet, and the pressure is in pounds per square inch PSI. And you can write PSI or pounds per square inch for yourself. Whatever you like is fine. Let me read this. We're first being asked what the pressure is at the surface of the water. So generally in these, unless you're being asked about your slope, you'll either be given a D value or a P value. And if you plug that in, you should be able to find whichever one you're missing. Here, we're asked what is the pressure, so we're not being given P. We're saying what is P, and we're not told a number, but it's hidden here at the surface of the water. That means your depth is 0. You're not underwater at all yet, so you're being given D equals 0 and asked for P. So you'll just want to plug that 0 in for D, and that should give you your P. And remember, function notation may be a little bit new, but when I say what is P, that's the same as saying what is P of D. P and P of D are kind of interchangeable. The P of D is just emphasizing the fact that it's the pressure you get from plugging in a depth. The second part is asking for a depth, so we're not going to plug in a D. We're looking for a D. At what depth is the pressure exactly double the pressure at the surface? Okay, so again, they're making us work for it a little bit. You should have an answer to the first part. I don't know what it is, but say it's 5 psi. You'll need to double that. So here you'd say, okay, it's 10, P equals 10, and plug that back into your original equation, and you'll have a little bit of solve to do. So your number won't be 10, I'm imagining, but you would be solving an equation like this for D. So whatever goes in here is just double your previous answer. What is the pressure at a depth of 132 feet? And they want you to use your function notation. So yeah, so maybe it's a bit of a function notation piece, and I don't think that's a hole you have. That's definitely something that we're assuming is fairly new to you and is largely the territory of 151, but we want to introduce it here. So we are saying that D is 132, and we want to find P. So what is P? And they're asking you to really use your function notation here. So we're saying plug 132 in for D. So that's your function notation. And then you'll actually have to plug that 132 in for D on the other side and do that calculation. But that, use function notation in the first box, that's what should go in the first box. P of 132 is whatever you get. And then since you're getting a pressure, your unit should be PSI. And then the last one, what is pressure at a depth of 330? Okay, so very similar for that one. So I'll let you try that one. Tell me if you have any trouble with it. Okay, last one is back to slope. So those are, I think, the two common pieces I see are the function notation and maybe a little bit with the slope. But again, this one might just be that sometimes when you get into a word problem, it just feels trickier. So we are looking for... Oh, I'm sorry, it's not just slope, it's a full equation. Write an equation for the number of miles traveled as a function of the amount of fuel used in gallons. So miles traveled as a function of fuel used in gallons. So miles are going to be Y values and gallons are going to be X values. Starting with a full tank of gas, if you use 11 gallons, so that's G equals 11. Your car can go another 251 miles before you run out. So it's really like miles remaining. And let me just, I don't have room there. There we go. Write an equation for the number of miles traveled as a function of the amount of fuel used. I think this actually is a little trickier than I thought when I picked it. I don't hate it, but it is a little bit tricky, because we're not being given, we aren't being asked for miles remaining, we're just asked for miles traveled. However, I don't think it's a big problem because that really just affects like what's your y-intercept. Are you looking at how many miles are left or how many you've already gone? And if we're saying how many miles we've traveled, we should be starting at 0. So like our y-intercept should be 0, which means all we really need is a slope. So we're really looking for how many miles we go. We're looking for like a miles per gallon, basically, which we can get from the information we're given. But I think that intercept part is a little tricky. So what do we have? 251 miles to go and then 194 miles to go. So if we take that 251 minus 194, the 251 went with 11 gallons and the 194 went with 14 gallons. This is going to give me a negative. It's saying because the number of miles left in my trip is decreasing, but it should be the same rate as how fast our mileage is increasing, just which direction you look at it. Either you look at it as you start and the number of miles increases that you've traveled, or you could look at it as the number of miles left is decreasing, but the rate is the same. So what am I getting here? 57 miles. And then, like I said, this is going to say -3 gallons, but if we just kind of flip-flop our perspective, we've used 3 gallons of gas to go 57 miles, or we have 19 miles less left in our trip per each 1 gallon that we've used up. So this is miles per gallon. Miles probably want an I in there. So again, you do have this funny perspective shift where you say, okay, if the number of miles left is decreasing by 19, then the number of miles traveled is increasing by 19. So I would say your equation here with function notation, did they tell us variables are M? Yes, I didn't just make that up. Miles as a function of gallons is 19 miles per every 1 gallon. So 19 over 1 times G. And then again, if we're making our perspective how many miles since the beginning of the trip, then that's going to be a 0. Okay, hopefully that helps a little bit. That one was a little tricky to talk through as well, but I do like the way you have to pick a slope out of that. I just think it's a little tricky the way they've flip-flop perspectives within that problem. Let me know if you're still feeling a little shaky about something, but hopefully that got you started on these.